Question number 26 is on inserting a dielectric slab between the plates of an isolated charge capacitor. The potential difference and potential energy stored will respectively. See, this was your capacitor which was having certain amount of charge Q and it was given a potential of V. Now when you introduce the dielectric in between, then what happens? Its electrical capacity increases and capacity become equal to K times the original the capacity. Now see, it is isolated, so the charge is constant. If the charge is constant and charge is capacity into the potential, therefore the new potential is equal to Q divided by this one. So K is always greater than 1, so this value will decrease, so potential decreases. Now what about the energy? Energy will use the formula potential energy Q square by 2C, and you see that C increases, therefore the stored energy will decrease. So both potential and stored energy decreases. So answer to this question is the option number 4. The question number 27 says a resistance of 6 ohm is connected in one gap of a meter bridge and unknown resistance less than 6 ohm is connected in the other gap. When the resistances are interchanged, the balance point shifts by 20 centimeter. Neglect and correction the unknown resistances. Now, dear student, this is the bridge, and this is your length, meter bridge over 100 centimeter, and he says 6 is the resistance here, and there is a resistance with value less than this one. Now, under the balance condition, you will get somewhere the balance length as L in the galvanometer, and you know by the balance bridge condition that 6 divided by L should be equal to R divided by 100 minus L. Therefore, 6 by R is equal to L divided by 100 minus L. Now R is the resistance you want to find out. Now what he performs, that these are interchanged, and this is 6 here and R is here. Now the balance point will shift. Now see, R was less than 6, so balance point should be closer to this, and definitely it will shift to left. So this become L minus 20, and what will this? The remaining length 100 minus L minus 20. Now again I write the equations likewise. So I write that R divided by L minus 20 is equal to 6 divided by 120 minus L. So therefore 6 by R is equal to 120 minus L divided by L minus 20. So we compare equation 1 and 2. So therefore L divided by 100 minus L is equal to 120 minus L divided by L minus 20. Now you solve, so L come to be 60 centimeter. So if his L is 60 centimeter, so we can find that 6 divided by R is equal to 60 divided by 100 minus 60, that is equal to 6 by 4. Therefore R is equal to 4 ohm, and the answer 2 is 4 ohm. So look at the question number 28. In streamline flow along a streamline, the velocity of fluid particle everywhere remain constant and uniform. Not true, because somewhere where the cross section decreases, the velocity will change. And the second part is the velocity of all fluid particle crossing a given position is same. Yes, that's a true statement, that at one cross section each particle and its predecessor will have the same velocity. So, let's look the third. The velocity of fluid particle at given instant is constant. Not the velocity of the fluid particle remain constant. That's not true. So the correct option to this is option number 2. The question number 29 is that surface tension and the vapor pressure of the water at 27 degrees centigrade are given 6.3 10 to the power minus 2 Newton per meter and 2.1 into 10 to the power 3 Pascal respectively. The radius of the smallest spherical water droplet which can be formed without evaporating. So it should not blast by surface tension. The excess pressure P is equal to 2 times the surface tension divided by the radius. Now smallest radius we'll calculate from here. R is equal to 2t divided by p. Will value, and surface tension is given 6.3 10 is power minus 2, and the excess pressure is given 2.1 into 10 is power 3. So this cancel 3 times. So R become is equal to 6 into 10 is power minus 2 and 10 is power minus 3, and that is equal to 6 into 10 is power minus 5, and which is equal to 60 into 10 is power minus 6, and that is equal to 60 micrometer. So answer to this question is the third one. Now see, the question number 30 is the graph between the two temperature scale P and Q is shown in the figure. Between upper fixed point and lower fixed points, there are 100 equal division on the scale of P and 100 division on the scale of Q. If the scale Q reads the temperature of body 60 degree, then the reading given by P. Now see, the temperature of Q is 60 degree given, and you have to find the temperature corresponding to the scale. Now the general concept is that the temperature minus the lower fixed point divided by upper fixed point minus lower fixed point is equal to the constant, right? Upper minus lower in both cases 100 given, and the temperature P minus the temperature P has the lower fixed point as this value. This is 130, so this should be 30. So minus 30, and upper minus lower, this is 100, and that from here is equal to the temperature, which is given equal to the 60 minus lower fixed point is 0 in this case, and divided by 100. So Tp minus 30 is equal to 60. Let's cancel out. Then Tp will be equal to 30 plus 60, and that is equal to 90, the value. So Tp will be 90p. The answer to this question is the third option.